My name is Emma Myers, and my thesis is about the effect of capsaicin on adolescent problem solving. I was inspired to do this thesis because throughout middle and high school, I noticed that spicy food was an extremely popular snack among my peers. And I realized that there might be a subconscious appeal towards these foods. Therefore, my research question was whether spicy food, aka capsaicin, had a positive influence on adolescent problem solving. In addition to seeing whether there was a subconscious appeal, another purpose of my study was that students would be able to eat spicy food to improve their focus and to improve their critical thinking during studying and tests. Capsaicin is a chemical found in peppers that, when eaten, causes a strong burning and spicy sensation. This occurs because when one is eating spicy food, the capsaicin in that food binds to the TRPV1 receptors in the mouth. When these receptors receive the message, they send another message up to the brain that says that the mouth is burning. When the brain receives this message, it sends dopamine and endorphins down to the mouth. It does this because endorphins and dopamine are both neurotransmitters whose job is to relieve pain, reduce stress, increase happiness, and increase focus. This results in a phenomenon known as capsaicin euphoria, where one, although eating spicy food and in pain, is in an extremely good mood. An element important to problem solving is memory. This occurs because problem solving is critical thinking, and critical thinking occurs when one uses their own knowledge and their own knowledge of past events in order to solve problems. And in order to do this, they must be able to recall information. This is relevant because my research involves the use of rodents and testing their spatial memory in relation to capsaicin. For example, one of my studies researched whether capsaicin could prevent symptoms of Alzheimer's disease in rats who were medically induced to have Alzheimer's. The control group was not fed capsaicin, while the control group was fed the experiment group was fed capsaicin, and they were put through a series of tests that tested their spatial memory and learning. The results of that test found that the rats fed capsaicin had significantly better spatial memory and learning and less symptoms of Alzheimer's disease. Similar studies showed that rats and mice fed the same chow food were shown to have much higher levels of spatial learning and memory. So the methodology of my experiment was using 30 high schoolers ranging from 9th to 12th grade and 14 to 18 years old. Their personal information was not gathered because of privacy according to IRB guidelines. The independent variable was capsaicin, and this was given in the form of Lay's Flaming Hot flavored potato chips. Each participant was given 6 grams of these spicy chips, and I chose to administer capsaicin through chips because in a real life setting, people are going to eat food instead of raw capsaicin, especially in the case of adolescents. They are more likely to eat it in the form of a snacky junk food such as chips. The materials I used were Snafu's Make a Cube puzzles by Mindware, which are puzzles that can be constructed to make a 3D prism. And my second material was a cognitive test on Microsoft Forms that I created using questions from the cognitive reflection test, the remote association test, and various IQ tests. The procedures were that the experimental group was fed 6 grams of chips, and then all groups were given 5 minutes to complete the Snafus Make a Cube puzzle. Afterwards, they were given a laptop and 10 minutes to complete a cognitive test, as you can see here. In addition to this experiment beforehand, I did give them a preliminary survey in order to collect demographics, as you can also see here. This preliminary survey also collected consent, as according to IRB guidelines. The results of my experiment, as you can see here, showed that the experimental group had higher points for both the puzzle and the quiz. Points were collected by treating the puzzle as 1 question and the cognitive test, which had 8 questions, as 8 points. Therefore, there were 9 points in total that each participant could earn. Although the experiment group had higher points earned for all groups, when the results were put through a t-test in order to determine whether the results were statistically significant, meaning whether or not the results were gathered randomly, it was found that the points earned for the puzzle section of the cognitive test were not statistically significant. However, the points for the quiz and the total points, the latter of which I used to determine whether my results supported my hypothesis, were statistically significant. As for the preliminary survey, which tested the demographics of the student body interested in my experiment, it found that the majority of the participants' school levels was 9th grade, the participants' ages 15 years old, the participants' sex female, the participants' experience with spice being an average spice tolerance, the participants' general spice tolerance, the participants' experience with spice was having eaten spicy food very often, and whether eating spicy food a student studying, the vast majority of participants in the survey said that it did not. However, I believe they said that this did not aid them in studying simply because they either did not eat spicy food while studying, or they did not have an appropriate measure to determine that, and so they chose no as a default answer. My limitations to this experiment is that I did not have a base test which would have determined whether someone was just naturally gifted at a cognitive test and had an unfair advantage over others, and that the Snafus puzzle cubes may have been too difficult for the 5-minute time allotted for each participant. Implications for future study may want to focus on spatial problem solving, as I was expecting the puzzles to have more statistically significant results. I do believe that future studies that focused on that facet of critical thinking might have much different results. and would have different implications. I also think future studies may want to test the correlation between different spice tolerances. Most of my volunteers really enjoyed spice, and so I think it would be interesting to see whether one got the same results from people who do not like spice and would not normally volunteer in an experiment like this. And I also think that future studies should have more diverse groups tested, as there was a higher skew of females and ninth graders in my study. In conclusion, my original hypothesis, which is that high school students consuming capsaicin would have higher speed and accuracy, is supported by my experiment results. Specifically, participants in the experimental group performed significantly better than the control group on the written portion of my cognitive test. Therefore, students can use capsaicin and spicy food in order to improve their focus and problem solving when studying. Thank you very much.